All right, Abdul, you're working as a network engineer, looking to enhance your career further. Got it? Makes sense. All right, guys, good to know. Thank you so much for sharing your insights. And meanwhile, if anybody else is joining, we'll let them join also. Okay. Also, if anybody wants to ask any question while we are discussing the whole thing, you can ask it in the chat anytime. Or if you want to unmute and say anything, we'll just give you permission to unmute and say that also. Okay. However, in your live class, whenever you'll be coming to the live class of training with Jatin, which is starting from 20th May, 9 a.m. Okay, the real class is starting from 20th of May, like, after 2 weeks from now, 2 weekends from now. Then you'll be able to unmute yourself. You can turn on your camera. You can, share your screen and everything. Those permissions will be available at that point. Okay. All right. So quickly, we'll jump into what is CCNA and everything, and CCNA, as you know, is the basic and the first certification that you or a training that you have to do when you enter into a network field, right? So Jatin, if we can quickly go through, the content that we'll be covering in CCNA and CCNP and core and NRC, right? And parallelly, what I'll do, I'll also, I'll keep jumping in between and then helping out in terms of what is the career in networking, and how after CCNA or after CCNP you can get placed easily as a network engineer or as a fresher, as a fresher, as well as a network engineer or system engineer, which you're already working, guys. Okay. Jatin, over to you, man.
Thank you. So, hey everyone, very good morning. So, as like already mentioned, I'm going to take your classes for the upcoming week, like the CCNA training. So, let's just quickly jump into the context, like what are the specifications we are going to discuss in the CCNA trainings. So, if you'll see the CCNA official course content and whatever the trainings, like we will be discussing CCNA, we'll be talking about CCNP, NCORE, and NRC as well. So according to the official syllabus which Cisco is giving, so each and everything we are going to cover up as per the official certifications. But the best part with the PyNet Labs is that with this syllabus, like if you will be talking about the CCNA specifically, so as that's an entry level certification where like we have some 6 topics if you will look the official course content. So the first thing we always have is the network fundamentals. So when we are going to discuss the network fundamentals, so there are lots of things in the network fundamentals, like as per the blueprint, if you will see in the blueprint, you will find that architecture part is there, routers are there, basics of networking are there, what are access points, some points related to wired and wireless networking. So including those official points which are mentioned in the official blueprint of CCNA, there are many other things which as a network engineer or as a fresher you have to understand, which means to say like we can take an example, like basically we will be discussing what exactly a network is and what exactly the difference between network and networking is. So OSI model is also a topic which is not basically being discussed and it's like not in the official blueprint, but we are going to cover that part as well because as a network engineer and if you are a fresher, you have to have a good understanding on the basic things, like you should know about what exactly the OSI model is, what are the types of cables which are used in networking. Apart from that, what are the network architecture topologies? Like previously, we used to discuss ring topologies, bus topologies. So such kind of networking basics are there. So all those things also will be covered in the network fundamentals, including the spine tree, three-tier topology on premises. So some cloud architectures are also there. So all these things we will be discussing in that network fundamentals, or you can say OSI model, TCP IP model. So a pretty basic thing, like which is not, we can say, the part of CCNA training, but yes, we in PyNet Labs are going to discuss that particular thing just because those things are very much important as a fresher to start and grow or more on the upcoming topics, because you must have the understanding. Now, once we have covered the fundamental parts, which is hardly gonna take 3 to 4 days, where we are going to cover IP addressing, subnetting, and so many things like that. Then after that, as per the blueprint, when you will see the next thing we have in the blueprint is the network access. So basically, when we are dealing with the network access part, so in this network access part, specifically, as per the official syllabus, the comparison is there between the wired and wireless networks. So what basically we do is initially when we start the CCNA trainings, we first cover the wired part because understanding the wired part is important. Like how many types of cables are there? What are the specific things which are related to those cables? How you are going to connect which device with which cable? Then specifically, once we are done with the wired section, we lastly move towards the wireless, where each and everything related to the wireless we are going to discuss. So that's one thing. Then IP connectivity is also there. So in the IP connectivity, a lot of things are there like DHCP services, network address translation, as well as you can say that some understanding of the routing protocols will be included. So all these things we will be discussing. And which this part you can see, like suppose the next thing we are going to discuss the services part. So in the services part, you will be getting the glimpse about the routing protocols, you will be getting the information about switching. So basically, this is what the official course looks like. If you will see the official blueprint, then we have some security. And then lastly, we have the thing which is automation. But according to the official blueprint of CCNA, if you will see, so you will be thinking that these things as a fresher, how we are going to get, but we are not going to cover things like with the official blueprint which is saying. So we do cover these things in a way that as a fresher you can understand, like initially starting from the fundamentals, then we move towards the switching section where we learn about the layer 2 technologies, what is switch and what are the protocols which can be configured on switches, what are the services which we can define on switches. Then once we are done with the switching part, so after that we specifically cover the routing part where all the routing protocols we are going to cover up. And instead of that, there is one more thing that as per this official syllabus, if I say there are so many things which are outdated from the latest syllabus, the paper code, which is CCNA 20301. So in this official paper code, there are many things which are outdated. Like Cisco has removed so many topics from the course content. Like for example, RIP protocol is not there. If I'm talking about the network address translation, in that network address translation, static net is not there. Dynamic net is not there. Only what we have in the official syllabus is the port address translation. And apart from that, some DHCP services are there, but not more in details. Like, I have seen in many training institutes that they don't discuss RIP protocol. They don't go in depth with RIP protocol. Like, they'll give you an idea what exactly RIP protocol is. But if you'll go more in depth about the RIP protocol, there is version 1, there is version 2. So including these versions also we are going to cover up. We'll cover up the network address translation because as per the industry perspective as a network engineer, if you are working in any of the enterprise network, so you must be having a good understanding about the topics which are not even there in the official syllabus. Like ether channel is one of the topic which is like not mentioned in the official syllabus, but you will be able to see that ether channel, we will be discussing a lot more things in ether channel, which is something like how you can configure it on layer 2 device, how you can configure it on the layer 3 device. So many things like that are there inside the training which are not the part of official content, but we will be delivering to you just because as per industry these things are really needed and these things are used as well, but many of the industries don't use, but many people use these things. So that's one thing. And apart from that, there is a one best thing about the CCNA 20301 that we call it as enterprise. And why basically we call it as enterprise? Because the previous CCNA was like about routing and switching only. So like many things were there related to routing and switching. But with routing and switching now, we are going to get some security fundamentals here, where in security we have a lot of things like ACLs we are going to learn. I'll give you a glimpse about how ACLs can be configured, some idea about VPNs, how basically VPNs are going to be covered up, but VPN labs are not there in that part. Yes, the Panshu.
Hi, thanks, Jatin. So quickly, just wanted to bring your attention to the chat box also that I've shared, three official links as well. If we can, open for Encore, CCNA, CCNP, Encore, and RC, those links as well, if possible, please, so that
Yeah.
people can watch it. For everyone else, you can also check out the links. So those are official content that is by prescribed by Cisco. However, like Jatin said, we'll be definitely adding on a lot of things because in 2020, when February 24, 2020, when a lot of content got changed and new versions came, they removed a lot of topics from the previous versions which were going on from last 10, 15 years. But sometimes change is good, but we still feel some of the old topics were very important, like Jatin said. So we'll go deep into those topics as well during this training, because that makes you industry ready specifically, right? Yeah. Then we can see only one screen, which is your PPT screen, I think.
Yeah.
And guys, if you have any questions, you can parallelly keep asking in the chat box quickly. And what is your expectation from this 1 hour that you're investing? Also, if you can share that in the chat box.
Yeah. Okay. So these are the things which we will be discussing in the CCNA trainings. And what we were discussing, that why we call this as the enterprise version, because this latest CCNA syllabus, which Cisco has recently announced, and there is a new version as well. So including the routing and switching, we are going to see some security fundamentals. Like, just let me share something with you. So just let me open the official blueprint.
So meanwhile, I think some people joined a little bit late as well. Quickly for you guys, the camera and the mic and the screen sharing for you is disabled here in this session. However, in the live class, it will be enabled so that you can ask your questions. Like I think Madhav, Jatin, Dinesh, Chetan, Arun, Narayan, you have joined just now. Mayank, you have just joined just now. Hi Pankaj, hi Parmar. So guys, you can ask your doubts and quick questions here as well, right? And your mic and everything would be enabled in the live class whenever you'll be coming to the live class, so that you can ask your doubts live, and you can share your screens as well while you're doing your practicals and all.
So here we go, guys. As you can see, that's the official course outline for the CCNA part, which we were discussing as of now. So you can see initially starting from the fundamentals part, a lot of things are there that describing the LANs and how basically the switches are going to work. As I already mentioned the point that when we are going to start, we will be discussing the fundamentals priorly. As you can see, describing the TCP/IP, IPv4 addressing part, even though subnetting is there, exploring the functions of routing. So before going towards the routing sections and switching sections, we will be discussing about the devices exactly. Like I'm not going to say like, suppose that if we are going to take an example, everybody knows what is a router, what is a switch. So it's a layer 2 device, layer 3 device, but instead of that, I'm also going to discuss the features and iOS things which are there with the devices, that what is the iOS version and how you can check that. What are the functions, what are the modes over the devices. So initially from each and every part, we can say that starting from the scratch, that this is how the device looks like. And once you are going to start the device, what is the very first thing and what is the last thing we can say. So that's how we will be discussing the labs, and parallelly, like we can say, we will be discussing more in details about the switching. As you can see here, that these are the topics like VLANs are there, and limitations about the routing part, basic IPv6 connectivity is there. And guys, one more thing with the IPv6 part. So like in IPv6, as per the official CCNA training, in the IPv6, there is just a given introduction about the address types, that what are the addresses in IPv6, but including the addresses, we will be also covering up the labs, like how basically you are going to define the routing protocols with the IPv6 connectivity, how other services can be implemented using the IPv6, not just the theoretical discussion. We'll be discussing the labs even though. So these things we are going to cover up. We'll see how basically the spanning tree is going to work, and you can now see the configuration and aggregation of ether channel is there. Layer 3 redundancy protocols, like we have FHRP, HSRP protocol, which are used for redundancy kind of things in the real-time environments. And you can see that describe the basic WAN and VPN concepts as well. So as in the new syllabus, so in the security section of the CCNA part, I'll be giving you the glimpse over VPN, not the labs we will be discussing in CCNA, but yes, how basically VPN works, how you can configure and how it exactly being defined over the wide area network. Including the security part, you can see the access control list is there, DHCP is there, and how basically the network address translation. Now see, as per the network address translation, I already mentioned that in the official blueprint, you will find that there is just one version of network address translation, which is port address translation, which as a network engineer, you must be having an idea. If you don't have the idea, no worries on that, because this network address translation is also having two different versions, which are not really used today. But yeah, those were used in the previous, in the traditional networks. And what are the drawbacks, that why don't we use those protocols today? So those protocols we will be discussing. Now you can see that the quality of service is also being implied in the CCNA syllabus. Then comes the wireless section, as earlier mentioned on the writing pad, that we will first cover up the wired section. And once we are good with the wired section, we are going to move towards the wireless then after, like completing the routing section. So we'll be discussing the wireless LAN controllers, how the wireless devices are going to work, even though not with just, you can see what is mentioned here that describe the concept of wireless networks and how to use wireless LAN controllers. So it's just not that I'll be showing you one device that this is a wireless LAN controller and how you are going to access it. But with this wireless specific topic, we can say I do have like some lab scenarios which we can implement to a packet tracer or any other simulator to verify that how exactly the wireless communication works. Because we will be discussing the wired part more in detail, and pretty much correlated with that as well, as per your CCNA concept, we will be discussing the wireless labs as well, which are not there in this particular official blueprint, but we are going to discuss that. Even though virtualization introduction is there, and now the very most important part, like which is like the very interesting section of the new CC and enterprise, which is the automation, where we are going to have a good and glimpse idea about what exactly the SDN is. That is nothing but the software defined networking, and how everyone is moving towards the software defined networking. But before understanding the SDN part, we need to understand the traditional network, that how exactly it is going to work and how you are going to configure the services and all these things inside the devices, how you can implement and deploy enterprise network. So then accordingly, once you are good with the routing, switching, and IP services, IP connectivity part, then after that only we'll be discussing this SDN introduction, differences between what was the traditional network, now why we need SDN, that's software defined networking. And we will be discussing the Cisco DNAC Center. So this is as such nothing but right now, as a network engineer or as a fresher, you have seen that whenever we are executing things over the devices, so it is all about, we can say that we basically just to control the local area network and all these things. So apart from this, that's the thing which we are going to discuss. And now just let's take an example that how basically we are going to cover up the complete training. Let's take just one simple example related to the OSPF, we can say. So that was the course introduction. Let me share my slide. Yes, Deepanshu.
Uh, Hi. Hi, thanks, Bhushan, for raising that. Yes, don't worry about it. It was just, we just wanted to compare from the content, official content, everything makes sense, obviously. So, guys, I'm asking you that, is there any topic that you would like to take up in the class today? Jatin, have you planned any topic for today? OSPF we are doing today, is it?
Yes, we can
Or
go with OSPF or any
so
other
guys, if you
topic
want to
like.
go for any other topic like subnetting you want to go, or you want to go for any other topic that you want to learn, you can share, and we can choose the whichever has more addresses, that whichever people want to do it. We'll wait for another 30 seconds if people want to share. Subnetting, good. Okay. Anyone else who wants to share anything? And also, since once you'll be joining the course and everything, you'll have what you call the lab guides, as well as the notes and PDF for all the topics that you'll be doing at that particular day. So we can go with, I think nobody else is responding accordingly. Jatin, you can go ahead with whichever topic you would like to, if you want. Okay. So Bhushan, NAT, SD-WAN, VLAN, IP address is good option. Okay. SD-WAN, Bhushan, we will not take in this session. Reason being, it is not required for freshers as well as people who are starting up with CCNA and CCNP as of now. But yes, NATing and VLAN can be done. IP addressing can be done. OSPF can be done. Okay. Now, Jatin, we have all the different, I think Yogesh said subnetting once again. Chetan, SD-WAN will not be picked up in this session. SD-WAN has a different demo class. So if you are looking for SD-WAN, I think you don't need CCNA, correct? If you guys are looking for SD-WAN right now, I think you already CCN, CCNP, you have good knowledge in that. If you have good knowledge in both of them, I think you don't need the demo session for CCNA. RIP is also one request that is coming. We'll pick whichever has more. So subnetting has two right now. Two people have said subnetting. We'll pick either subnetting or IP address, whichever you want. So if anybody else also wants to share anything, please share. Yeah, Jatin, let's pick up subnetting because Yogesh, Jatin, two people have said okay, RIP, IGRP, then different single vote coming on those things. We can pick subnetting in this one. Correct. ठीक है. That is what we are going for, Bhushan. Correct. Yes. So if you're asking for complete technical part, that is what we are going for right now in the subnetting. Jatin, we can start with subnetting. Okay. And meanwhile, if you want Jatin's other demo classes as well, you can speak to Nitish, Ayush, or Ravi, anybody who is you are in touch with already. You can speak to them once, and you can get the demo classes for other topics as well apart from this. Okay. Jatin, we can go for subnetting then. Okay. Please, we can start with
Yeah,
subnetting.
all right. Okay.
Thanks.
So let's see, guys, as the request is raised for subnetting. So we'll be discussing basically how subnetting is going to work and how we are going to define subnetting inside the real-time enterprise network. So basically, when we are going to discuss subnetting, what exactly the subnetting is, the very first thing we need to understand about subnetting, that it is just a process of, we can say, dividing one single network into multiple smaller networks. And how into multiple smaller networks we are going to define. Let's take an example to understand that. It's just going to help you in minimizing the wastage of IP addresses. Suppose that, let's take an example as well as let me share my packet tracer screen so that meanwhile we can have some parallel labs as well. So here we have our packet tracer. Now let's suppose that we are going to take a switch, and with the switch, let's suppose we are having a few devices. And let's say that so I'm basically going to do something like on all these devices, I'm going to execute some IP addresses. And as of now, I'm not going to get more in specific multiple devices or things like that, just because with 4 devices, we can see the same thing. So I'm going to take some IP addressing of class C. Let's say I am having some network of 192.168.1.1 on the PC0. And meanwhile, I'll also write the IP address that this PC is having some 1.1. Let's say this PC is going to have some IP of 1.50. So let's write the IP here 1.50. And apart from that, this PC is going to have some IP address of, let's say, 192.168.110. And this side, we are going to run some IP address, let's say 192.168.1.190. So you know that in one single IP range, when we are defining, we are going to say that it's going to have total valid addresses as 254 addresses. But as of now, I have executed, let's say 190 device, 190 up to the addresses. But if you will see now, if I want to make the communication in between all these PCs, so the communication is definitely going to be possible. And why? As you can see that if I'm going to drop one packet from PC0 to PC number 2, so it is saying the communication is successful. Now let's take an example. I got a company scenario where all these users are there. Suppose that I'm getting 2 different branch or you can say departments. This is my first department. That's going to be my second department. Assuming that this is going to be your IT department. And this is going to be your sales department. So these 2 departments are there in the enterprise network, and I got a company. In this company, this is a requirement. So back on the slide, as you can see, that with the same lab we are going to cover up. Let's take an example that in my company, I am having some accounts department. Let's say accounts department is saying that we have a requirement of 50 computers. Then we have some HR department. HR department is saying that we have a requirement of 50 computers. IT department is there. Again, IT is saying that we have some 50 users. And lastly, we have some sales department, which is having some, again, requirement of 50. So in every department, we have an approx 50 users, and my requirement in these departments is that these departments, I want to make sure that the accounts department will not communicate with HR, IT, or sales, like no communication in between these departments, but even though they should stay within the LAN. Suppose that as per the lab we did, as you can see on this part, like this was the requirement that suppose that this IT department is there, which should not be able to communicate with the sales department. That is one more requirement that comes up with the subnetting. So if I'll say that PC1 should not be able to communicate with the PC2, but it is able to communicate. So to block the communication, there are two possible solutions. First solution is that either you can go with different network. Right now, I'm using some 192.168.1.0 network on the IT department. And let's change the IP here. If I'll say 192.168.2.1, and I'll try to make the communication with the 2.1, so you'll see that there will be no communication. Ping 192.168.2.1. So you can see that there is no communication between two different networks. Now, just to make sure that you're going to have the communication between these two different networks, so in that case, you are going to have some routing protocols, but that is not the requirement right now. We are dealing with the subnetting part. So how basically subnetting will be helping you out? Because in this scenario, there is just one more thing which I would like to add before moving further, that in case if you are a fresher, this is like there are some prerequisites to understand the subnetting. Like you need to understand some IP addressing parts, you need to understand the classes of IP address. So these things we do cover in the network fundamentals, but as the like what was raised for subnetting part, so we are going to discuss it, but there are some prerequisites like you must have the understanding of IP addressing. You should know what exactly classful protocols are. You should know what exactly the classless protocols are, as well as like apart from this, we need to understand what is the subnet mask, what is the host portion, what is a network portion. So just to give it in a glimpse, I'll be sharing one thing that suppose you are having some network 192.168.1.0. So you know that whenever we are discussing the IP addressing part, that you all know this belongs to class C, because class C is going to have specific range. So which starts from 192 basically to 223. Now in this range, you can see that 192.168.1, this portion we consider it as the network portion. Where is the last zero? Or I'll change the color. So this zero portion is representing to the host portion, which means to say that this is something the 24 bits, which will be the network portion. And this is something the 8 bits, which is going to be the host portion, which can be any specific IP address according to the machine which we are going to define. Now, this is the syntax which basically we are going to use for class C. And now the requirement was that accounts department is having 50, HR is having 50, IT is having 50, and they should not communicate with each other. So if you are going to say that for the accounts department, I can use 192.168.1.0 network. Or let's say HR department, I can use 192.168.2.0 network. And for IT department, you can use, let's say 192.168.3.0. And similarly, like for sales department as well, if you're going to use 192.168.4.0 network. So, you know, guys, total IP addresses, like if I'm mentioning, so in just one range, there are 254 addresses, which will be valid addresses. So let's say 254, how? Because the first portion is like suppose 1.0, or if I'll completely write the range for this 1.0, so it's going to end up like this. 1.02, we can say 192.168.1.255, where I can say this 1.0 and 1.255. This 0 and 255 are excluded just because they are not being used over the devices. So total valid addresses will be 254, which we can define on the host machines. So technically, now if you will see that the requirement is of 4 different departments. So 254 into 4 you are going to do is, so in total IP addresses we are going to use is 1016. These are the valid addresses if you will see, because again 254 addresses will be used here, 254 addresses will be used in this network, and 254 will be used in this address. But the requirement which you have in the network is total of 200 only. So why we are wasting so much of IP addresses? Like total coming is 1016, and in that, if I'm going to use the total number of machines are 200. So let's say 1016 minus 200 if you'll do. So the results you're going to get is 816. Now here in this part, these are 816 IP addresses. You are actually wasting these IP addresses because that is not the requirement. The requirement is that you only want 200 users. Then why to go with different networks? So that's not a relevant thing to do in the production environment. So for this specific thing, we are going to use subnetting, where all the departments or all the users should be staying within the same local area network, within the same network as well. So this is how this thing is going to work. And subnetting is the possible solution which will be helping us to make sure that we are going to, use the same network, and these devices will even not communicate inside the network as well. So there are two different ways of doing subnetting. I'll say different ways of doing subnetting. So whenever I say the subnetting part, there are two types of subnetting actually. The first we have is FLSM, which is fixed length subnet mask. Second is VLSM. Now, what exactly the differences are there between the subnetting FLSM and VLSM? Let's take a scenario. Suppose that I got two production environments. This is my first in production, and this is again my second production environment. And inside these two production environments, I'll say first is for FLSM, second is for VLSM. Now, as of now, the thing we discussed that there is a HR department which is having requirements of 20 user or 50, you can say. Let's say that there is some IT department which is again having 20 users. Sales is there which wants 20 users. And apart from this, let's say there is some marketing department which wants 20 users. So in case of FLSM subnetting, whenever you are doing, so you are dividing the network into the equal parts where each and every network will be of equal size. But do you think that it is going to be a possible solution, or the enterprises are going to rely on FLSM? Because it's not like that. No company is going to have, let's say, the requirement like that. In HR, there will be 50 users or 20, you can say. In IT, there will be 50 users. So this is not a possible thing in the production environments, that each and every department of your organization is going to have the equal requirement for the users, because in every department there will be different users. Suppose that in sales department there are 5 users, and similarly if we talk about the VLSM, let's say in the IT department I am having the requirement of 100 users, and in the HR department I have the requirement of, let's say, 20 users, and sales team is having the requirement of 50 users, whereas marketing team is having requirement of 30 users. So as per the production scenarios, you will see that this is the possibility that every department is going to have different users of requirement. So basically, whenever we are saying the FLSM, the fixed length subnet mask, as the name itself represents, that where each and every network is going to be of equal size. But whereas in VLSM, we are just dividing the network. It can be equal or it may not be equal. We actually divide the network into variable sizes. So in the production environments, we are mostly going to use the VLSM kind of subnetting. So I'm just going to give you a glimpse about FLSM as of now, because understanding the FLSM is the prior thing, because that is the foundation. And once you are good with FLSM, then it is easier to understand the VLSM as well. So we need to understand that how basically we are going to do the subnetting. And apart from that, what are the requirements you need to take care of before doing the subnetting? But meanwhile, apart from this, if you guys do have any questions in this section, so you can do use the chat box and do let me know. So just let me check the chat box once. Or any other queries, guys, if anyone is having, so you can do raise your queries on the chat box. Meanwhile, we'll see the rest of the things, that how basically the subnetting is going to work.
Hi, Rajesh. So nothing much. We discussed about what CCNA syllabus and CCNP and core NRC syllabus would be like, and what all you'll be learning during your CCNA training. And we took one topic which is subnetting, and as a as a sample demo topic for today. However, this is not an actual training. This is just a demo class. Or Rajesh, you can also ask for the recording of this session. from Nitish, Ayush, or anyone from our team if you are already connected with anyone. Yeah. Or anyone else have any questions? Please feel free to ask in the session in the chat box. And meanwhile, Jatin, please check two questions that we have,
Yeah.
Bhushan and Anand.
So the questions in the chat box are the which topology can be used in subnetting. So in subnetting, it can be dependent upon the requirement that most of the time you are going to see star topologies are basically being used. But as such, there is no specification that we need to specifically define any kind of topology over the subnetting part, because it is just all about dividing the networks, dividing the users according to the requirement. So that is one thing with the topology part, Bhushan. And the second question we have is that why the 0 and 255 are excluded. So if you will see that, for example, we are taking a network which is 192.168.1.0. So it's going to start like whenever you are going to execute the IP addresses. So you will be writing the IP addresses like 192.168.1.1. And similarly, you will be ending upon 192.168.1.254, and the last IP will be 192.168.1.255. So the total range will be implied as per the 1.0 to 1.255. This is the complete range, 1.0 to 1.255. Whereas like this 1.0, if you will be executing on any of the device, it is not going to support, because this is, we consider it as the network ID. This is the first valid host. First valid host in the sense that this IP can be executed on any of the host machine. So that's one thing. And this 254 is the last valid host, we consider it as. And this 255 is going to be the broadcast ID. So the exclusions for 1.0 and 255 is basically that 1.0 is equals to the network ID and 1.255. So 0 and 255 will not be executed over the devices because these are the network ID and broadcast ID. So similarly, if you will see, like I can show you the same thing on packet tracer as well. Suppose this is my machine, and on this machine, if I want to write the IP of 1.255, and if I'll click here, see, invalid IP address for this subnet mask, because I cannot use this IP address in the host machine. Whereas if I'll write 192.168.1.0, so you can see again for 1.0, it's giving me that it's an invalid IP address, because this 1.0 will be used over the routing protocols just to advertise the network portion in the complete environment. So that's what we are going to deal with the exclusions. So we'll see these things later on. Now we can see that there is one more question we have, that what is CIDR? So I'll be coming on that point, but let's try to understand the ways of doing subnetting and what are the prerequisites and requirements. So guys, see, if you are going to define the subnetting, so in case of subnetting, it is something like we can say whenever you are going to configure subnetting. So basically there are some requirements. Suppose that if you are working in an enterprise network as a network engineer and your company is saying that we have to do some subnetting. So the requirement, first of all, you are going to give to your company is that what is the required number of hosts, that how many computers or how many users are there inside your company. So we'll say required number of host, as well as the second requirement is that required number of networks, that how many networks you want to configure inside the network. So requirement of host and requirement of network should be there, because whenever I'm going to allocate network, I'll also define the users and devices which needs to be connected. And as a network engineer, you are definitely going to ask these two questions to any of the manager, like who is saying to deploy a network, which is like how many hosts you want, how many networks you want according to the department. So whenever you want to calculate the number of hosts and whenever you want to calculate the number of networks, there are two specific formulas which we need to take care of. So in case if you want to figure out that what are the total number of hosts, so it is something we are going to use a formula which says 2 raised to power h minus 2, that should be greater than or equal to the required number of hosts. Now, what is 2 raised to power h minus 2 and why basically minus 2 is there? So I'll let you know what this formula when we will be doing the subnetting part. And whenever you are doing the requirement of network, like you want to calculate how many networks will be there. So the formula again implies like 2 raised to power n. That means it should be greater than or equal to the number of requirement, you can say. So I'll be explaining you these two formulas more in detail when we will be looking with the subnetting part. But there was a question raised, which was we can say that, the CIDR part. And with that, I'm going to say that we are going to say, suppose you are trying to, what exactly we will be doing in the subnetting part. Suppose that we have three classes of IP addresses. Let's say we have IP address, class A, class B, and class C. And with these classes, there are some things that there is a network bits, there are some host bits. So whenever I'm saying network bits, class A is going to have 8 network bits. Host are like something we can say 24 host bits. Class B is going to have 16 network bits, 16 host bits, and C is going to have 24 host bits as well as 24 network bits and 8 host bits. So this is the default size of the IP classes according to their network portion and all that. Now, which means to say, if I'll write the syntax as well, you will see something that I'm going to use the blue color for the network portion. So here the network portion, in class B network portion, and in class C network. So you know that IPv4 is total consist of 32 bits. So these 24 bits are going to be your network bits and remaining bits will be your host bits. Host. So these 24 bits will be host and here 16 host, and again here we have the host portion. So after doing the subnetting, we are just what we are going to do is we will be reducing the number of host bits in subnetting. So basically when we are going to reduce the number of host bits, automatically we will reduce the network size. So basically by reducing the number of host bits, we are actually going to convert them into the network bits, because by default, if you will see the size of 2 raised to power 8, if you are going to deal with that, so it's going to give you some 256, where the valid addresses are going to be your 254 addresses. So that's how these things are going to work. And apart from that, let's take a basic example to understand this complete part. And I have some 10 users in the subnet mask. So few questions are raised in the part related to the subnetting by Anand, that I have 10 users in the network. So the subnet value, how I'm going to use. So I'll be answering your query, Anand, but let's cover up this, subnetting part first, because understanding this part is pretty much necessary. Then we'll accordingly move towards the rest of the things. So let's take one example. I'm going to not going to take any kind of complex example, a very basic example I'm going to take. Let's say I'm going to deal with FLSM, which is the foundation of subnetting. And in this FLSM, I'm going to show you C class subnetting. And in trainings, we are definitely going to cover class A, class B with the labs as well. So these classes are also being covered, including the FLSM as well as VLSM. But as of now, as it's a demo class, so I'm just going to show you with the C class only. So let's say that there is a requirement of 50 networks, or let's say 50 hosts are required. Now, as per this requirement, there should be some network. Let's say the network I'm having is 192.168.1.0. So that's the network. And you know that the by default C class is going to support, let's say, I'm going to say C class is equals to, we'll be having some, just a minute. Yeah. So with the C class, we know that we are going to have the default range, which is basically going to start from 0 to 255. So that's one thing. And these are the total number of addresses. Now we'll divide the network into smaller sizes. So for calculating the host, in the previous slide, I told you that there is a formula. So now let's try to understand step by step. So the step one of doing subnetting is you're going to get the requirement of host, which is like the formula you have to execute, which is 2 raised to power h minus 2. That should be greater than or equal to the requirement. So the requirement right now you are having is 50 is the requirement. greater than or equal to, and 2 raised to power h minus 2. So basically what I'm going to do here is, there is something guys, we have to learn about the conversions and all these things here as well. As the 50 is the requirement and this is the IP address. So by default, it's going to have the /24 value. So there is a concept which is going to come up, like we call it as the CIDR concept, which is going to look like this. So let's say I'm going to say class A. So class A, I already told you that class A is going to have 8 network bits and 24 host bits. So if you have an idea about the conversions, like how the conversions are gonna be done. So like basically I can show you something that just I have a image I can paste here directly instead of writing. Just give me a minute. Let me share my screen.
Meanwhile, Jatin is doing it. So, guys, I have quickly created a form for you. I'm sharing it in the chat box as well. So I can see some of the questions that are coming. So, for example, Rajesh, you have asked, I'm a system administrator. How can CCNA, CCNP help me? So we'll have to understand, what is your current experience been like, and what you have been doing in last few years, and how is your, experience in terms of system administrator. But because see, one keyword system administrator will not be able to give us a what you call insight that what you're doing exactly. So a lot of people get on offer letters as network engineers also, but they're actually doing some other work, right? Or desktop support engineer or system. So we'll have to understand what you're doing so that we can guide you what will work right for you. Is CCNA CCNP for you or not? That also will suggest you. Okay. If anyone else has that kind of questions or want one-to-one counseling with our team, me, or anyone else, you can fill out this form and our team will reach out to you within next 48 hours. So I mentioned 3 slots here: today, tomorrow, and day after tomorrow. Yeah, you can reach out to us accordingly. I think somebody has raised the hand as well. Yeah, Usnaveen, you want to ask anything, you can put it in the chat box if you would like. Meanwhile, if you want me to allow you mic, I can allow you mic as well. Yeah. So Bhushan, I think you're in touch with Vikhyat or somebody from the team as well for VLAN NAT concept and everything. What we'll do, we'll quickly share Jatin's recordings with you over the WhatsApp once, okay? Because for the demo session, I think we have some freshers as well here who won't be able to understand, because parallelly on the chat, some students have mentioned to Nitish sir and Ayush sir that we are not able to understand subnetting because they are freshers. They do not have, like Jatin also mentioned, some people do not have idea about how things will work. Obviously, in the class it will work, but what we can do for you, Bhushan, just to help you out personally, please connect with one of our teammates that you're already in touch with. They will send you VLAN and NAT complete class recordings of Jatin from the previous batches. Okay, so that you'll be able to watch that. Meanwhile, Jatin, you were saying something. Please continue.
Yeah, thank you. So as we were discussing guys about the IP addressing part, and there was a query raised again for the CIDR part as well. So CIDR is as such nothing, but it stands for classless inter-domain routing. So you know that whenever we are going to do the IP conversions, suppose that if I'm going to say that there is a IP address or there is a subnet value, let's suppose that there is a IP 192.168.1.0. This is the network portion given to us. And with every specific IP address, whenever you are going to define any kind of IP address, there is something which automatically comes up and we consider it as the subnet mask. So subnet mask with every class is a default value. Let's say with class C, we are going to have 255.255.255.0. Now here, this 255.255, it represents that this is the network portion, and this last zero is going to represent the host portion. So forget about the host portion as of now. When I'm dealing with the network portion, this 255.255.255, all these 24 bits will be like 1, 2, 3, 4, 5, 6, 7, 8, 1, 2, 3, 4, 5, 6, 7, 8. And this is how it's going to look in case of binary conversions if we are going to see. So if I'm talking about the /CIDR value, so the /CIDR value will represent 24 in this scenario because the number of ones are 111. So 24 times we are going to see the conversions. Like you can see 1 this 25 255 255 according to that. So like not getting more in details on the conversion, just I have some images to show you. You can see there are some /CIDR values which are written here. So if you are trying to see, let's suppose that /8, which is basically used for class A. So this is the subnet value you will be using for class A. Let's say /16. this is gonna be the slash value for class B. And if I'm saying /24, so that means we are talking about class C, where the default subnet value will be 255.255.0, like the way we discussed here. So the slash value /10 will be representing the 255.192. Suppose that if I have some /25 value. So in case of /25, whenever we are doing the conversions, so here like we are going to say this bit is going to represent 128, and accordingly like that we move towards the conversion like 1, 2, 4, 8, 16, and like that 132, and like that 64 and 128. So basically if I will be saying that if I have a slash value of 25, so this conversion will be 128, and the subnet value will come like 255, 255, 255, and 128 for the conversion of /25. So this is the CIDR value which you can see here. /25 is representing this, and /26 is like representing 192, which means 128 plus 64 you are going to get is something that where we will be discussing this particular part where this /CIDR will be coming up. So all these things we are basically going to discuss more in detail when we are will be in the live trainings, because we have to understand the IP addressing part completely to go over so many things like that. So understanding the IP part is primarily important, and accordingly, like by the conversions, you can see that if you are going to deal with the /10 value. So if I'll say /10 means that 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and rest of the other values will be 0. So this 1, 2, 3, 4, 5, 6. So like this /10 will be represented where all the values will be 1. So if you will be converting this value, so you are going to see that 128 plus 64. So you will be getting 255.192.0.0 for the /10 subnet value. So you can see this is mentioned here. So that's just an overview which I have given to you. Now I'll be back again on the slide which we were discussing about the subnetting part, where we have some requirement. Now let's say 2 raised to power h minus 2, I'm going to say, where my requirement was the 50 host. Now what exactly this h represents? This h represents number of host bits which we will be using in here. So there is something you need to take care of, the 2 power table when you are going to understand the subnetting. So understanding the 2 power table is also pretty much prior. So if you need to like check about what exactly, I can write here for you as well. Let's say that if we are dealing with the 2 power table, so 2 raised to power 2 is equals to, you are going to get some 4, and 2 raised to power 3 you are going to get some 8 value, 2 raised to power 4 you are going to get is 16, 32, 64, 128, like the way we are going to see. But we need to take care of the requirement as well. So now my requirement is 50. So in the 2 power table, let's say 16 is there, 2 raised to power 5 will be 32, 2 raised to power 6 will be 64, 2 raised to power 7 will be your 128. Now, why I'm writing this 2 power table? Because see, the requirement of your host machines was 50, and the formula says 2 raised to power h minus 2. So here in this formula, which requirement is satisfying? That you can see I can use 2 raised to power 6 because 64 is satisfying my condition, which is the requirement of 50 haste. Because I cannot use the 2 raised to power 5, because let's say if I'll say 2 raised to 5 minus 2, so it's gonna give me some 32 minus 2. So that is something 30, and my requirement of host is 50. And the formula says the requirement should not be like should be greater than or equal to the requirement. So I'm not going to use this 2 raised to power 5. I'll be using is 2 raised to power 6. So I'll say 2 raised to power 6 minus 2 greater than or equal to the requirement. So it's going to give me 64 minus 2, 62, which is greater than or equal to the requirement. So I got the number of host requirement, that this is my number of valid host. So 62 is equals to number of valid host per subnet we will define. So that's the step one, to figure out the number of host. Now the second thing is we need to figure out that how many host bits we require. So basically as you will see that if I'll write the conversion of IPv4 class C address, let's say 1, 2, 3, 4, 5, 6, 7, 8, 1, 2, 3, 4, 5, 6, 7, 8, 1, 2, 3, 4, 5, 6, 7, 8. Okay, just one more is missing. All right, we can write. Now we have host portion 1, 2, 3, 4, 5, 6, 7, 8. So this is the requirement of host here. Now inside the host portion, what is the 6H represents the number of host bits, and this 6 we are not going to use now, which means to say I'll start from right side. 1, 2, 3, 4, 5, and 6. These are not used because you have used as 2 raised to power 6. So these values will not be used now. Now remaining two, what I previously mentioned when we were discussing the part that in subnetting we convert the host bits into network bits. Now the remaining 2 bits of your portion, they will be converted here as 1 and 1. Now the total value you are getting is 24 bits were already there, 24 plus 2. So you are getting some 26 bits. Now if you are having 26 bits, so that is something the CIDR we got right now is /26. So for the /26, you can see the subnet value. This is gonna be the subnet value for /26. Because if I'll say the subnet mask C class is going to have the default one 255, 255.255 dot. Now 2 bits you have converted from the host portion, which means to say 128 plus 64. You're going to deal with that and it's going to give you 192 like it's there in the CIDR chart as well. So this is going to be the subnet value. Now this is how you're going to figure out the number of host bits. And apart from this portion, the next thing is this is the step 1 to get the number of host requirement. The step 2 is like we have to take care about the block size. We need to figure out the block size, that how many we can say the number of machines will be there per network, we can say. So let's say this is something as per the concept. The requirement was 50 computers and we got the host valid host we got is the 62, because if I was using 2 raised to power 6, 64 was there, so I have -2, so valid host are 62. The subnet value which we got is 255, 255, 255.192. So that's one thing. And there is a third requirement, which is the total networks as well. Now, to get the total number of networks, you have the formula 2 raised to power n. Now, this n represents the number of converted bits. So how many bits we have converted in the range? You can see 2 bits were converted. So you are simply going to say 2 raised to power 2, which is going to give you the total number of networks as 4. Because these 2 converted bits are there, which is going to give you 4. So total number is network of 4, valid host is 62, and this is the subnet value. Now we need to find the block size. So if I'll say the block size is as such nothing, but we can say how many users will be there per block. So to find the block size, 256 minus whatever the subnet value you are getting, new subnet value, which means to say 256 minus 192, and the block size I'm going to get is 64. Now, if I'll write the range, that is the very important part in doing subnetting. So what I'll do is I'll simply say that the block size is equals to 64. Now the requirement was 50 computers. Now you will see 64 into 0, 64 into 1, 64 into 2. So 0, 64, and 64 into 2 is going to be 128, and then we have 64 into 3, which is going to result in 192. So you will see this part. This is something the block size I have figured out, and why I'm doing this multiplication, just because I will make you understand how you can easily write the ranges. So if you will see, now the very first network range, it's going to start like this. If you are getting 0 here in the first block, that means 192.168.1.0, and you are going to end up on 192.168.1.63, where 1.0 is going to be the network portion and 63 is going to be the broadcast ID for this first block, which is, let's suppose, HR department. Second is IT department. Third is sales department, and similarly marketing department. And second range will start 192.168.1.64 is going to be the network ID, and it's going to end on 192.168.1.127. And then we have 192.168.1.128, and then it's going to end on 192.168.1.191. So these are the ranges. So I'm not going to discuss all these ranges theoretically. Better to like go with the packet tracer. I can show you the same thing over the lab as well. That how basically we have divided the network and how it's going to work. So just a moment, let me reshare my lab screen. And we'll also make sure that we have some advanced, or we can say extra users in the lab. Let's make it a bit more clear. And let's say that I'm going to remove all these things. This is my switch here. And with this switch, let's say I'm going to take 1, 2, 3, 4, 1, 2, 3, and 1, 2, 3 again. 1, 2, 3, 3 PCs also you can take. So I have 4 different departments now. This is my first department. We can name it as any IT sales or any other department, whatever you like. Then again, third department I am having, and then I have the fourth department as well. Now I'll connect all these users with the switch. And accordingly, you will see that the ranges which I'll be defining on all the users. So just using 2 PCs on the third department, not gonna use because like we have to execute the IP address on each and every device manually right now because there is no DHCP. So this is like our scenario where I'm having 4 different departments. So if you will see that I'm going to mention, this is gonna be the sales department. This is gonna be the IT or any other department. This is second department. And this is gonna be the last department. And let's write the names as well. This is your sales department. So sales department, let's say, is having the range of 192.168.1.0 to 192.168.1 dot. As per the range 0 to, you will see the slides. The first range was 1.0 to 1.63, right? So I'll say 1.63. That's the range for sales department. Similarly, if I'll say here, it's going to start with 1.64, where 64 is not usable, and it's going to end up on 127. So 64 and 127 will not be used in this department as well. I'll show you the same thing. And let's say this is not the sales department. This is going to be the IT department. And this is, let's say, MKT marketing department, where I'm having the range of it is starting from 1.128 to 1. We can say that it's going to end up on 191. And then lastly, I am having some, let's say, backup department, where the range I'm going to have is 192.168.192 to, we can say, 192.168.1 dot. You're going to end up upon 255, where 255 will not be usable. So that is one thing. And as I can see, that if I will be defining this IP addresses on these machines, so you can just execute the same configurations over the devices, but you need to make sure that the subnet mask you will be using is 255.255.255.192 on all the machines instead of using the default. So what I'm like not going to execute all these IP addresses on these devices because it's going to take a lot of time. So you can try the same thing in your own packet tracers, and that's how we are going to divide the network with the help of subnetting. Like you can take one example on 2 devices. I can show you 192.168, let's say 1.1, and subnet value I'll say 192. And similarly, if I'll say on the next department, this is having some range of 192.168.1 dot. 70, where 192 is the subnet value. So if I'll try to ping 1.70 with this IP, which is 1.1. So if you will see ping 192.168.1.70, so you can see there is no communication because we have divided the network. But in case of this, if I'm going to change the subnet values, like if I'll go here and use the default one /0, and here also if I'll use the default values /0. So now you will be able to see the communication is going to happen. You can see now the communication is happening. So that is how we are going to deal up with the subnetting, and that's how basically we are going to define the subnetting. And that's just the basic overview, but more in detail, we will be discussing all these things in the upcoming trainings and in the live classes as well, with the labs as well, using FLSM, VLSM. So that's just an overview. So that is all for the subnetting part. Now you can have the Q&As, like if you do have any sort of queries with any of the part, because that's what we are going to discuss as of now in just the demo section. So you can raise your queries in case if you do have any kind of queries related to the technical part.
All right. Nishant, yeah, you can contact. I've given a form above. You can quickly check that form. You can fill that form. Our team will contact you accordingly. This is the form for you. Also, everyone, I hope the session was useful. And if you have any questions, feel free to ask in the chat now. If you would like to ask in the chat, or if you would like, some other demo topics, like I said earlier, also like Bhushan requested and a couple of other people requested for VLAN, SD-WAN, and other. If you want those sessions recording, you can request that also in the form, and you can, our team will give it to you particularly. Yeah. Also, apart from this, if you would like to know about, like Nishant just asked that, how about the placements and everything? With CCNA, we'll be able to assist you. We also have a Telegram group. If you have not joined the Telegram group yet, you can join the Telegram group that is available for free of cost. You don't have to pay anything for that. And in that, we keep sharing a lot of job openings a lot of times. Almost every week we have 4 or 5 openings that we keep sharing. This is not just a forwarded openings. Our team is getting these openings. When these openings are not getting fulfilled by our own job guarantee student, we put it publicly in the Telegram group. Okay. Then others from other training institutes can also apply. People who have done trainings from other people. Okay. Or if you have already have knowledge, and if you don't want to learn anything, you can apply. But if you want to go for job guarantee programs, I've shared another link here in the chat box. You can quickly check that. And whenever you would like to ask any questions on that, you can fill the form, and our team will contact you accordingly. Yeah. Thank you, Yogesh. Thank you so much. Really appreciate it. Thank you, Jatin. Really appreciate it. And if you have any questions, our team is always available on Telegram, WhatsApp, email, and chat, or call anytime. You can always speak to us. Yeah. Also, I have received around 7 people have requested for one-to-one counseling. What I'll do, will be connecting with you today and tomorrow, whichever timings you have mentioned. Okay. Telegram link, please check. I've already shared. Pankaj quickly. Yeah. Okay. Jatin has also shared. Nishant, we have received your details in the form below, and we'll be connecting with you. Okay. All right, guys. I think that's it for the day, and we'll be wrapping up this session. This Teams chat will be active for another 10 minutes or 15 minutes at max. And thank you, Jatin. Thank you so much for patiently taking and helping out everyone. Thank you, Raju, for coming. Thank you, Abhishek, for joining. Thank you, guys, everyone, for devoting your Sunday at 9 a.m. in the morning, and coming here and leaving your family and work aside. Yeah. Thank you, everyone. Thank you so much for the time, and all the very best. Stay connected.